Bismillahirrahmanirrahim. Assalamu alaikum everyone. I am Dr. Shazia Shahani here, Associate Professor of Anatomy, Department Pumps Nawabshah. Today we are going to discuss the remaining slides of the liver. We discuss its location, vascular supply, histological structure, so last time we did the concepts discussion about the classical hepatic lobule, concepts of liver lobule. We did classical hepatic lobule. This classical hepatic lobule, it is a liver lobule that is drained by a central vein. So blood flow from the peripheral tracts to center of the lobule. So this is the central classical hepatic lobule. Here central axis is formed by central vein. So in this hepatic lobule, blood flow from the peripheral portal tracts towards the central vein. Another is the portal lobule. Today we are going to discuss details of portal lobule and the liver acinus or hepatic acinus of Rappaport. So in the last lecture we did the classic hepatic lobule. Again have a little review about the classic hepatic lobule. It is central axis is formed by hepatic vein. Blood flow is from the portal triad area towards the central vein. So hepatocytes that radiate irregularly from the central vein, these are called as the hepatic lamina, and the spaces between the hepatic lamina are called as the hepatic lacunae. These are the liver cords or hepatic plates. They will form the hepatic lamina. In between the hepatic lamina, there are the spaces called as a lacunae, which are filled with the hepatic sinusoids, are occupied by the hepatic sinusoids. So here is the micrograph which shows the hepatic lobule or classic liver lobule. Here's the central vein. These are the portal areas. It is roughly hexagonal in shape. So here is a more close view. Central vein. These are the hepatic cords. In between them are the hepatic sinusoids. These are the liver cords. In between them are hepatic sinusoids. Liver cords will form the lamina of the liver and the hepatocytes, and the liver sinusoids occupies the lacunae of the liver. Lacunae are the spaces between the lamina or liver cords. So hepatic sinusoids, little more about the hepatic sinusoids. They are wide diameter capillaries. These are actually fenestrated capillaries. They have the pores in their walls, are lined with the fillet epithelial cells, and their walls, there is attachment of Cooper cells. You can see here the Cooper cells. More close view. Here are the hepatic cards. So blood flow of classical hepatic lobule from the periphery towards the central vein. It receives the blood from the inlet venule and the arteriosinusoidal branch of the terminal branches of the hepatic artery and the portal vein. Here hepatic sinusoids receives the blood from these venule and arterioles, and it flows towards the central vein. After central vein, it flows towards the sublobular vein. From the sublobular vein, it drains into hepatic vein, and through from the hepatic vein, it drains through the inferior vena cava into the right atrium of the heart. Here is the more close view. Hepatic sinusoid receive blood from the terminal branches of the portal vein and hepatic artery, and it flows towards the central vein, sublobular, then hepatic, and then the inferior vena cava into right atrium of heart. So the portal area, peripherally, each lobule has 3 to 6 portal areas with more fibrous connective tissue, each of which comprises of a portal triad, which consists of a branch of portal vein, a branch of hepatic artery, and one small bile ductules, one or two ductules. So a branch of portal vein which contains blood which low in oxygen and rich in nutrients, while the arteriole branch of hepatic artery which is rich in oxygen, and one or two small bile ductules of which are lined by cuboidal epithelium. These are the branches of bile conducting system. So here are the portal areas which contain the portal triad, terminal branches of hepatic artery, portal vein, and the hepatic ductules are portal veins. So bile canaliculi are found between the spaces. Here you can note in the diagram. Here's the hepatocytes. In between the hepatocytes, there is the plasma membrane. The bile canaliculi are formed by the spaces between these plasma membranes of adjacent liver cells. They form a hexagonal network around the hepatic lobule. It formed the hexagonal network. Look at the cursor. It formed the roughly hexagonal network around the liver lobules. So these canaliculi formed between the spaces between the two liver cells are hepatocytes. These are sealed by a tight junctions. They form a blood bile barrier. They prevent the mixing of bile with the blood because there is a space of DC. That space is present between the endothelial cells of sinusoids and the hepatic lamina. As you see there, here there are fenestrations in the endothelial cells, in between the endothelial cells, which easily allow the prelocation of the plasma which is present over here in the space of dizzy. There is a plasma and other cells, most important cells, ITO cells, are present in this space of dizzy. So these tight junctions prevent the mixing of bile with the blood. So this tight junctions will form the blood-bile barrier. The canaliculi pass to the periphery of hepatic lobules. These are the canaliculi. These are intralaminar. They are inside the lamina. Lamina contains the hepatocytes. So these bile canaliculi are, when passes to periphery of hepatic lobule, they will form a canal. This canal is now known as the herring canal or canal of herring, which opens or drains into a bile duct, a branch of bile duct or intralobular duct of portal area. So these bile canaliculi are intralobular and centrifugal in direction. Flow of bile is from the central vein to outwards, while flow of blood was from the periphery towards the central vein. So bile flow will be in opposite direction from the central vein towards the periphery. Here you can see bile canaliculi. These are the intralaminar bile canaliculi. You can note here in this hepatic cards. These bile canaliculi, when they reaches towards the periphery of hepatic lobule, they become converted into the canal of herring, which opens into a branch of bile duct. Again, bile canaliculi, canal of herring, which opens into the branch of bile duct. So space of Deci, little detail about the space of Deci, or perisinusoidal space, how this space is formed. Space is formed between the walls of sinusoids. This is the wall of sinusoid and this is the lumen of sinusoid. Here you can see the lamina of the liver cells are hepatic cords. In between the wall of sinusoids and lamina of the hepatic cells, there is a space. This space is called as a space of Deci or perisinusoidal space. It contains the blood plasma and chylomicrons that percolates through the walls of sinusoid. There is also a presence of ITO cells. Let us discuss about the ITO cells in the coming slides. Here you can see endothelial cells, Cooper cells, RBCs, wall of lumen of sinusoids. This is the wall of sinusoid. Here you can see there's the fenestrations through which chylomicrons and plasma easily percolates into this space. This space also contains ITO cells. Here's the micrograph of histology. Here is the liver sinusoids and hepatic lamina. In between the lamina and the endothelial cells, here you can note the space of Deci or perisinusoidal space. Again, here you can note these are the hepatic cords and the liver sinusoids. Here is the endothelial cells. In between endothelial cells and lamina, there's a again perisinusoidal space. Here also you can note perisinusoidal space. ITO cells, these are the regular cells with numerous lipid vesicles. These are the cells, ITO cells, irregular walls having outline irregular with the lipid vesicles. These cells are responsible formation. They are responsible for formation of collagenous material, as well as they are responsible for the formation of growth factor, which is necessary for regeneration of damaged liver cells. They also secrete collagenous material and store vitamins A in their lipid vesicles. So another space is a space of Mars between the Glissen's capsule of the portal area and the hepatic plates of these cells. Here's the space of mall or periportal space. Periportal, a space around the portal area. Here's the space between the Glissen's capsule of the portal area and the hepatic plates of the liver cells. So importance of this space is lymphatics of liver begins here. Here are the lymphatics which begins at the level of periportal or space of mall. Here is the another portal lobule, most important portal lobule. It is responsible for secretion of the bile. It is concerned for bile flow. It performs as an exocrine function. The territory of liver tissue centered around a portal triad. A territory of liver tissue which is centered around the portal triad. Here it is marked by joining the central veins around a portal triad or central veins around a adjacent portal lobule. So it is a nutritional lobule of the liver. Here you can see a micrograph, 3 central veins of 3 adjacent liver lobules, and here you can note the portal area. Hepatic acinus or liver lobule or liver acinus. It is a diamond-shaped liver acinus. Form structural and metabolic functions of the liver. Numerous branches. Look at the cursor. Here's the 2 portal areas in between 2 liver lobules. These numerous branches arises from these portal areas at the right angles. They will form the backbone of the liver acinus. And this acinus having 3 areas, 3 zones, which is basis on its blood supply. First we look at the here's the portal triad. Here's the portal triad. These are the central veins of 2 hepatic lobules. Here's the diamond shape. The blood vessels which are arising at the right angles. These terminal blood vessels arising from these portal triads, they will form the backbone of this liver acinus. So this liver acinus can be divided into 3 zones based on gradient of their blood supply. As in this diagram, you can note this is the liver acinus having 3 zones, zone 1, zone 2 and zone 3, which is based on the gradient of their blood supply. Zone 1 containing the blood vessels which are right angles. They are arises with the right angles of this acinus. This area is rich in blood supply. Zone 1, zone 2, this area is moderately supplied by the blood, and least supplied by the blood is zone 3, which is nearer to central vein. So this part of acinus can be easily anoxic to the injury. Here is the zone, zone 1, highly vascular, zone 2, moderately supplied by a blood, least supplied, zone 3, so easily can be damaged by anoxic injuries. So the last slides, the hepatocytes, these are the cuboidal or polyhedral epithelial cells with larger nuclei, central nuclei, and eosinophilic cytoplasm. It contains the rich number of mitochondria, Golgi apparatus, mitochondria, and the lysosomes. So here is the all about the histology of the liver. Kindly स्क्रीनशॉट लेके अटेंडेंस आपकी मुझे इनबॉक्स करें या व्हाट्सएप नंबर पे सेंड कर दें. So if you have any query, kindly inbox me. Thank you all.